Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. Everyone, welcome into the program. Today on the show, we have the one, the only, Mr. Ralph Bond. He'll be joining us here in just a moment to talk about everything science, tech, and more. He's our science and tech trends correspondent, of course. And yeah, these stories are always a lot of fun, especially on a Friday. So speaking of which, everyone, I hope that you are having a fantastic Friday so far, and we can go ahead and make it a little bit better. So computeramerica.com, that will have everything, including past shows, future shows, show notes, articles, social media, links, and more. And of course, any of that you want to catch up on, Computer America is the best place for that. We'll also have a link over to Ralph's site, and Ralph's site is obviously Ralph focused. You can find all of his segments if you want more Ralph, because a lot of these stories, which is the fun part, are research, they're cutting edge, they're new, they're perspective, things that you might see in a couple of years. So even though if you go back, 6, 7, 8 months, a year or more, the stories are still going to be very, very relevant. So, be sure to check that out. Now, with that being said, why don't we go ahead and bring Ralph on and just, have fun with it. This is a good Friday, not the Good Friday, but a good Friday. And everyone, it's going to be a lot of fun. So Ralph, welcome back onto the program. How you doing?
It's great, Ben. It's great to be back. And our first two stories today are in the world of medical advancements, which is kind of fun. Well, personally, of great interest to me.
Well, there you go. Yeah, and I'm sure to a lot of people, because it seems like medically, obviously, timeliness, effectiveness, being able to catch everything is important, but also ease of use is, seems to be, ease of administering these things is going to be helpful for everyone. So
yes,
but we'll get more into that with those particular ones. Why don't you go ahead and tell the nice folks what your goal is when you come on the show here to do these articles?
You got it. If you're a first-time viewer, listener for the show, here's what I do. I'm an aggregator of science and tech news features I find by monitoring a host of online news outlets. And I look for important, and sometimes they're goofy, wild, crazy stories that don't usually capture mainstream press attention, or they're very significant stories, to be more serious, that because of the news cycle, just don't fly up and don't bubble up into the mainstream press. And I'm always on the lookout for news that gives a glimpse into where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it, across the board. And my job as the correspondent for science and technology trends, that's what I'm looking for. Things that may not be here today, but give us a glimpse into the future. And what I do with each news item is present the essential points and in a digestible form. And I stress to our audience to check out the show notes that will be posted on computeramerica.com and on my website as well, because we'll have pictures, links, and so forth, because Ben and I are just going to give you the highlights today of each of these stories. If you want to dig deeper into the science or technology, that's why you need those links. That's why you need the show notes. And I encourage you to come out and check that out.
For sure. And there you go. So with that being said, Ralph, I think story number one, we should just, kind of get right into it, because, some of these cancer tests, very invasive, very hard to do. And, actually, from a personal standpoint, my fiance's father just went in for, he had a growth behind his eye. And let me tell you, luckily, everything's benign. Everything's fine. It's
good.
And we just found that a couple days ago. But what I want to say was, finding a person to kind of get to the source of the cancer and test it was almost as tough as, I'm sure, trying to find an actual surgeon, because it was behind the eye. You needed they did need a brain surgeon to even get to it.
Oh, wow.
It was, my point is, it's not exactly what this article is about, but getting to the cancer can be half the struggle to even tell if it is something that you have to worry about. So story number one.
Exactly, Ben. And also along those same lines, just finding the cancer, being able to sample it and test it and analyze it. It's all part of the war against cancer in our bodies. And our first story headline here is, now there's an easy to swallow test for esophageal precancer. And I'll explain this as we get into this. And I got this story. It was really interesting. The people from an outfit called Esoguard, that's Esoguard, contacted me and said, we have a story we think might be of interest to you and your audience based on your coverage of medical technology in the past. And I said, sure, bring it on. And it turns out to be something that for me personally is of great personal interest. Several times in my life, I've had the procedure called an endoscopy. But I'm jumping ahead here a little bit. Let me set the stage here. So here's something that's terrifying. More than 80% of patients diagnosed with cancer in their esophagus caused by chronic acid reflux die, yikes, within 5 years of diagnosis. I'll tell you a little personal story in a moment that made me, my hair just, what's left of my hair just went on fire when I read that statistic. Remember this, though, the esophagus is the muscular tube that connects the throat to the stomach. So if you're not familiar with that term, that's what we're talking about. The pipe that goes from your throat down to your tummy. So typically, generally speaking, and I've had this several times myself in my life, a procedure called an endoscopy is used to detect esophageal cancer in a patient's upper digestive system. Now, I've had this done several times myself. Ben, I don't know if you've ever had this done, but it involves inserting an endoscope, which is a tube-like instrument to view inside. So there's a camera, so you can view inside the esophagus. You move down and up and down the esophagus. And you can also take tissue samples for analysis. And often sedation is needed. In fact, for me, I've always been put out for this, which is fine with me. But now there's a clever and much less invasive alternative. And before we go on, I'll give a little personal story. I guess it was probably about 15 years ago. I was just, my father had terrible acid indigestion. I just thought, well, you're a dude and you're getting older and that's just life, and get over it and deal with it. But one morning I was sitting down having breakfast with my family, and I swallowed a piece of toast or something, and it just got stuck. And it was just the most painful thing in the world as it slowly, as the muscle groups in the esophagus slowly pushed it down. I thought and I was sitting there just in pain. And my wife said, that's it. You're going to the doctor. So I go to the doctor. I describe the symptoms, and I'll never forget it. The doctor said, you idiot. You should, if you've been having years of chronic acid reflux, blah, 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 blah. So right away, get me to a specialist who does the endoscopy procedure. They send the tube down. They took, after the fact, they said, we took 20 tissue samples from your esophagus, Ralph, because you are a terrible mess. And they were very glum and very serious because I didn't know about that 80% prediction of dying in 5 years.
Wow.
Now, the good news is the test came back, and I'll never forget it. The doctor who did the procedure said, Ralph, I cannot believe you didn't have horrible cancer in that esophagus. It was in such terrible shape. We just figured you were a dead man, and said, somebody's looking out for you. So, folks, the moral of this story is, if you have chronic acid reflux, please talk to your doctor. Please consider getting this test, whatever form of test you get for an endoscopy, because it's serious, serious business. Okay, now, with all of that said, we talked about the tube, going down, sedation. Now there's a clever and much less invasive alternative. It's very interesting for me, at least. It's called Esoguard. Again, that's Esoguard. It was developed by researchers at the Case Western Reserve University a few years back. I think they released it in 2018, but now it's getting deployed, okay? And here's how it works. In a test that takes less than 5 minutes, you swallow a capsule about the size of a vitamin tablet, and that capsule is attached to a very soft, very thin line, okay? So you swallow this thing, you take little sips of water and help it go down. And once it's in place in the esophagus, the capsule inflates like a balloon. and it gently swabs the inside of your esophagus to collect cells. And then the balloon, after the procedure is done, the balloon is inverted back into the capsule and then gently pulled out, so you to avoid the gag reflex, right? And then the captured cells are then sent to a lab for an Esoguard DNA test to help diagnose potential esophageal pre-cancer or cancer itself. And then within a couple of weeks, you get your results. And for me here, living in the Portland, Oregon area, we, starting in March, had a facility operated by Lucid Diagnostics that administers this test. So I was able to tell my KEX Portland audience about this for us locally. But if you're interested, just Google Lucid Diagnostics and see if they have a center in your area, if you're interested in this, or if you want to discuss this with your doctor. But I thought this is pretty interesting. I was skeptical and wondering about how do you swallow this thing and not have gag reflex, but they figured it out and they've got a formula and it's working, and you can see videos on this and so forth. Pretty darn clever alternative to the very involved, invasive bit of putting you out, knocking you out, and sending a tube down, right?
Right. Yeah. And if you're watching the video portion, you can see, they actually have the video there, and they even have like a side-by-side comparison of, a daily vitamin or a gel cap. And this thing's actually about half the size of a daily vitamin. So, daily vitamins aren't exactly the smallest thing in the world. But it's it's small enough, and it shows the video of it going down and collecting the things. Does seem much better than having to put you down. Well, put you to sleep. It all sounds bad, but still, Ralph, thank you for sharing that story. And I just want to say that this is a fight that I'm having with my parents, especially my mom, because she was. She's the kind of person that will just kind of, deal with it, in her words. She just deals with it. That's what you do. You just, something hurts a little bit, but whatever. As we, as we get older, I think that mentality leads to the worst patients, because you just deal with it. You don't mention it to your doctor. You don't mention, that it's like, my Achilles tendon's been bothering me for a couple of years, but I've just been, whatever. Next thing you know, you can't even use that foot anymore. If things start hurting, talk to your doctor. That's very, very important.
Yeah, absolutely.
So that's just mine.
Yeah.
But with that being said, Ralph, that is a really, really cool story. And I'm very excited that they were able to reach out to you and kind of share that with you, because, that's almost breaking news. I saw that, they kind of came up with this at late last year, but very, very cutting edge. And I'm glad that they did. So Esoguard, very cool. And ladies and gentlemen, we'll have a link in the show notes. So story number 1, story number 2, let's go ahead and, this one is... really, this one's crazy. Surgery, but in the final frontier, I guess. So story number 2.
Yes. And unfortunately, folks, just before we got on the show here today, I was able to find a really, really good video, which I sent to Ben, and he'll be able to play it for us. But the headline here is: a surgery performing robot is ready for tests on the International Space Station. And I got this from a couple of sources, one being gizmodo.com and the other being CNET, and other outlets were covering this story as well. But here's the story. A surgery performing robot developed jointly by the University of Nebraska-Lincoln and medical technology company Virtual Incision is ready to be tested aboard the International Space Station. And the robot is called MIRA, M-I-R-A, which stands for Miniaturized In Vivo Robotic Assistant, and can be operated remotely by a surgeon on Earth as a non-invasive way to perform surgical procedures in space. Wow. And you can see the video with Ben showing you how articulate this thing is. So this is something amazing. Let this sink in. The result of 20 years of development. 20 years of development. The 2-pound robot basically looks like a white rod or tube-like thing with 2 small arm-like attachments. And again, the video does such a great job of showing how articulate these little arm attachments are. And on the end of each arm are plier-like grippers to hold the surgical instruments. And again, they're controlled remotely using sophisticated, the video shows this too, very sophisticated joystick-like hand controls. And that doesn't really do them justice. They're much more sophisticated than just a stick, right? And again, the video shows that so well. And here's the bottom line. If all the tests go well on the space station, the benefits of this kind of remote robotic surgical tool would not be limited to space. It could also make robotic assisted surgery accessible in any operating room potentially on the planet. So feature this. You're a super expert in some kind of, you're a doctor, super expert in some form of surgical procedure, perhaps like the story of the tumor or whatever behind the eye that you mentioned at the outset. Yeah. And you need a real brain surgeon specialist, but you are in an area, a rural area, you're someplace where it's not likely to happen, or this one expert is in such high demand. Well, that expert potentially could sit in their office with this system and perform procedures on a patient thousands and thousands of miles away, let alone space, right? So it's what I love about this is the motivation was initially to give the ability to do medical procedures in space remotely, but the on-Earth applications are really, really exciting for this. It's a great, great breakthrough in 20 years of development. Think about that.
Yeah. And really think about how much technology has changed in 20 years. It's very, very, I'm sure that not just the speed of data transfer and the lowering of latency, but also just the miniaturization of everything. Very impressive. What I was kind of liking, and you can see it up there on the video, but these, this thing's pretty small. And I can imagine a scenario where if not a surgeon or another surgeon, you can have one surgeon in person there working on someone, and you can have someone else controlling this because it's so much smaller. Like it's almost the size of the size of a human hand, that you could have something very articulate, not getting in the way, but able to assist with a surgery, and just not be physically in the room, not be physically taking up space, yet able to do even more. So
I was going to say, Ben, in terms of size, to your point, remember again in the notes it talks about it's only 2 pounds. Mm-hmm. This is not a big bulky. Yes, there's an armature and there's a setup for it. Let's not diminish that, but the unit itself is very portable.
Right, very, very portable, very tiny, and wow, the point I was going to make had completely went out the window, but still very, very cool.
Sorry about that.
And, no, I got it again. Ladies and gentlemen, to reiterate, this is a robotic surgery platform, not so much an automated AI-controlled robot surgeon that will do everything for you. So this is something that, much like a video game, a surgeon has controls and will control it, and then that will do things in real life. So, it's a robotic surgery platform, not a robot surgeon. Still crossing our fingers on the second one.
Oh, yeah. And Ben, this raises a good point. Because at the outset, when you say robot surgical, everyone jumps to the conclusion that it must mean it's an autonomous AI-driven thing that can just do its own thing without human intervention. Right. In the world of robotics, one of the things that's kind of every once in a while trips me up as well is that sometimes robotics can apply to, and this is a terrible comparison, puppet-like things. In other words, things that are controlled by a human, but they're accentuated or augmented by robotics. So robotics doesn't mean autonomy all the time. It doesn't mean the robot has no control from a human. It's a hybrid kind of thing. It's a human machine blending. And that's one of the things that's interesting to me about robotics. It's a pretty broad umbrella that embraces things beyond just self-contained R2D2s or something like that.
But it's all applicable, and this one's very, very cool. And the fact that it's going to the space station of all others, I never really considered that. The space station is like a giant science laboratory just floating in space, and you never really consider that. People go up there and they live up there, but you never really consider that they might need surgery up there. And maybe they always have maybe, and I don't know if the ISS does this, but if they always have a surgeon on board, like if they always have like a medical expert on board at the space station at all times. But hey, this could be very, very helpful for, I'm sure, a lot of different applications. And Ben, a little pickup on that too briefly is you get into the articles, and what they talk about is, sure, it's going to be tested
on the space station. But the real vision for this is for human occupation long-term on the moon, Mars, and so forth. They have to figure out some way to account for unexpected medical emergencies and problems and so forth. And again, once again, this could be the kind of thing that could be deployed here on Earth in medical helicopters, or go to sites of problems and deploy this thing and set it up potentially, maybe. But again, the mission is, from the space side of the mission, is for long-term habitation support. That's what it's really all about.
I could definitely see a future where you walk into the emergency room, you have a big cut in your arm, and you're like, it's like, I had an accident, and they say, go over to the booth, and they send you to a booth, and there's one of these things that's only job is to stitch people up, because the particular arms that they had on this thing, one was like a clamp and one was kind of like scissors. Maybe this thing would just suture people up. This would just sew people back up. And you could think of like, military applications, on the field or in the field. And
absolutely.
Stuff like that. Lots of different life-saving capabilities. So very, very cool. Story number 2. And, and actually, Ralph, if I'm not mistaken, that's like the second time that we've heard from like the University of Nebraska and research coming out of there. So, because I remember the first time we mentioned, you thought Nebraska, not the most prominent place for scientific and medical research, but
no, it's amazing, isn't it? Some great stuff going on in our country and in the heartland of our country too.
Definitely. So, story number 2. Story number 3. Let's go ahead and check this one out. This is something that I think people consider, but at the same time, when you build a dam, hydroelectric, that kind of thing, these big old turbines, they shoot water out, they churn. And I guess the first thing that pops into, or one of the first things that pops into people's heads is go, wow, imagine if you were to get sucked into that. That'd be awful. And hey, I'm sure fish feel the same way. So story number 3 kind of addresses that.
Yeah, and in fact, a little setup on this too, as you know, but maybe if you're new to the show, I live in the Portland, Oregon area. So this has a very powerful northwest angle to it. But the headline here is Fish Safe Hydroelectric Turbines Offer a Compromise Solution. And I'll explain this compromise business. Got this story from MIT News. You can see images here in the show notes of what these things look like. But here in the Northwest where I live, we've heard a lot. I mean, right now, a really flaming hot issue up here is the controversial proposals to dismantle existing hydroelectric dams. And we rely here in the Northwest on hydroelectric source of energy, a great deal. But the idea is, the problem is the salmon population, the migrating fish, they're really, really endangered right now. And one of the dramatic, and some say drastic, proposals is, okay, well, we're going to have to go to the, dismantle some of these dams and be rid of them. And people are saying, well, that's all well and good, but how are we going to replace the electricity, and on and on. It's just this terrible controversy. And, but there's a fun, interesting thing with this story. But it kind of said jokingly, what if we could have our cake and eat it too? And this is where this outfit comes in, Natal, Natel Energy, Natal Energy. It's a company founded by 2 brothers, both of them graduates of the Massachusetts Institute of Technology. That's kind of cool. And they've created a fish-friendly hydroelectric turbine. And before I go on, I want to just stop for a moment. Up here in the Northwest, a lot of times what they do with these hydroelectric dams is they make diversion channels that they try to encourage the fish to use, that safely guide the fish through the situation or the area where the dam is and so forth. And that works to some extent. But let's get real. There's still a lot of fish bite the bullet when they go through these turbines up here.
I think this is a typical, and if you're watching the video portion, you can kind of see it there. That's what a typical dam setup it looks like.
Correct.
Yeah.
That is correct. Right on target. That's exactly what we have too. And it works, but it doesn't completely work. It doesn't solve the whole problem.
Because fish are, fish are friends, but at the same time, they're pretty stupid. They're just fish. So, they're still going to get into accidents. So, even if you guide them,
Oh yeah, Ben. And the other thing to consider in your illustration, these turbines, they're pulling the water, the force is going to divert a number X percentage of the fish through the fans, and they're going to get destroyed. So the Natal guys, the Natal brothers, Natel again, with their new fish-safe turbines, combined with other features designed to mimic natural river conditions, the founders of Natal Energy say hydroelectric plants made with or retrofitted, ding, 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 keep that in mind, retrofitted with their technologies could help bridge the gap between power plant efficiency and environmental sustainability. And in this case, the sustainability means supporting the migrating fish populations. So the turbine the Natal brothers developed features thick blades with extremely rounded edges that allow more than 99% of fish to pass through safely, according to third-party tests. Wow. Okay. And Natal's turbines also allow for the passage of important river sediment and can be coupled with structures that mimic natural features of rivers like log jams, beaver dams, and rock arches. So their vision is combine these fish-friendly turbines with these other little accessories, if you want to call it that, to imitate natural river features, and still maybe have those pass-through channels that you showed in your illustration. Mm-hmm. If you have that combination, this could really help the fish survive, help maintain salmon, but at the same time continue to allow us to have the hydroelectric sources. And Natal has already installed 2 versions of this latest turbine, what they call the Restoration Hydro Turbine, at existing plants in the state of Maine, and ding, 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 right here in Oregon, where I live, at the Monroe Hydro Project in a town called Madras. So, wow, it's for us in the Northwest, this is a big deal. I'm sure, of course, in New England and elsewhere where migrating fish populations are an issue, and certainly this is true in Canada as well. This could offer a great hope to retrofit. I think the thing here would be, how cool will it be if you could retrofit existing dams with these fish-friendly turbines and just go on from there? I think that would be a great good compromise solution.
Yeah, and as much as we kind of cross our fingers on, wind and solar, kind of saving the day, we need a little bit of everything for sure. So
yes.
This is a great compromise. And, I actually saw one the other day that was very, very similar, but this one, and I've spent this whole time trying to look for it. They put a hydroelectric generator in the middle of a river, Ralph, and it was vertical. There was no floodplain, there was no dam, fish could swim around it. It was like a big tube that they stuck in, and because it was kind of elevated a little bit, and the water would naturally flow into it and then flow down the tube, that was pushing turbines that would then generate the electricity. So it was almost like you just plop a big tube in the middle of a river, and that was enough to start generating. Obviously, not enough, not as much as a full-blown dam system, but it was much more eco-friendly and much less disruptive.
I love it.
So, little things like this will definitely help in the long run. So that was story number 3, and great for the fish. If you're a fish, congratulations. There's hope for you too. Story number 4, though. Story number 4. Yes. This is going to be another one, and this time by someone who, you often hear about these stories about young kids, coming up with revolutionary new ways, and always wonder, do they just see it differently or something? But it's always good to know that, hey, if you're one of those pessimists that say the next generation, they're all lazy and dumb and they're rude and blah, 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 whatever the Aristotle quote was. No, not so much the case. There are great people in all generations. And story number 4. Yes.
A great way to end our show today. So upbeat. So here's the headline. 17-year-old genius develops electric motor that could transform the auto industry. And once again, I kind of modify the headlines from the original articles to make them a little more personal for me. But I got this from the Smithsonian Magazine. I just love this story. I love it, love it, love it. So today's electric car motors require magnets. And the magnets are made using rare earth elements, which can cost hundreds of dollars per kilogram. This was a real education for me. For example, a Toyota Prius can use up to 33 pounds of one rare earth material. This is one of the things that makes EV cars, cost factor expensive, right? And so what are the rare earth metals used in electromagnets. I did a little side research here.
Yeah.
So there are four rare earth metals or lanthanoids used in electromagnets are lanthanum. I'm going to try to say this as best I can. And neodymium, dysprosium, and terbium. And I'm not going to say it again because it's too hard to say. But there's four of them, okay? And so what is the main source of magnets today? I'm just doing a setup here to show you what the problem we have as a world trying to get to EV cars, okay? So the major source of magnets today for EV cars is China. Some countries classify rare earth metals as strategically important, and recent Chinese export restrictions on these materials have led some people in the community, the science world, to initiate research programs to develop strong magnets that do not require rare earth metals. Okay? So with all of this in mind, 17-year-old Robert Sansone from Fort Pierce, Florida, became interested in a type of electric motor called a synchronous reluctance motor. And Ben, it's an electric motor that does not use costly rare earth materials because it's not based on using magnets. Okay. So what is a synchronous reluctance motor? We're going into classroom mode here for a moment. A synchronous reluctance motor is an electromechanical energy conversion device which converts electrical energy to mechanical energy. Okay, like all motors. The motor always runs at synchronous speed due to magnetic locking between the rotor magnetic field and the stator magnetic field. And to be frank, I don't fully understand this, but that's the definition. So a synchronous reluctance motors are not using magnets. Rather, a steel rotor with air gaps cut into it aligns itself with the rotating magnetic field. Reluctance, or the material's magnetism, is the key to such a process. I am not going to say I fully understand this.
So
you can dive deep into it. Maybe you can offer some additional insight, Ben.
Yeah, and if anyone wants to send me an angry email, go for it. But it sounds like you have a mechanical rotor turned by electrical energy. So, it can be battery fed, for a car, and then through the use of magnets. So it's not generating the force with magnets, it's generating it with, an actual motor. And then the other side that's going to go into the other side of the car is then matched with magnets. So it's not generating anything with magnets. So you don't need super strong rare earth metals from China. You just need, a typical steel magnet or whatever to then create the force that goes to the other parts of the car. So So it's not using the rare earth magnets, but it is still using magnetism, just not the hard to pronounce rare earth metals that you talked about earlier.
Yes, right.
Right.
Yes, exactly. So with all of this in mind, this young man, 17 years old, remember this. So after 1 year of development, Robert created a small-scale proof of concept electric synchronous reluctance motor that could theoretically be scaled up to power a car. And the show notes show a picture of this young fella here with his prototype. And in fact, his invention is so potentially game-changing for the auto industry that it captured the first prize in this year's Regeneron International Science and Engineering Fair. First prize. Wow. Now, as we've been alluding to here with some of our comments a few moments ago, there's a ton of what I call mind-melting science and engineering details behind Robert's invention that are fully explored and explained pretty well in the Smithsonian article. So if you want to learn more, come out to computeramerica.com, of course, and get the show notes for today, and you'll find a link to the Smithsonian article and with all the details, and you can dig as deep as you want. And I'll end here with a comment from Robert himself. He said, rare earth materials in existing electric motors are a major factor undermining the sustainability of electric vehicles, seeing the day when electric vehicles are fully sustainable due to the help of my novel motor design would be a dream come true. Think about a 17-year-old with that kind of articulate mind and just genius. And again, there is great hope, Ben, you're serious. If you don't write off the current generation of teenagers, big mistake. There's some genius, wonderful stuff going on out there, and support science, technology, education, and math, so-called STEM programs in your local schools. Please support them. There's probably another Robert out there or Roberta out there waiting to be discovered.
Exactly. And this one's so cool, reading a little bit into the article, he was able to get it to 750 RPM before his, the parts that were available to him, which were plastic, 3D printed, I'm sure, things like that, started to melt. A typical car can get up to about 6. Well, they mentioned a Tesla, Ralph, 16,000 RPM. So, 750 versus 16,000, still a ways to kind of scale it up. But
yes,
it's such great promise and such a great story. Love to hear it. And, Ralph, when you hear about, some people like to make the claim that electric vehicles are not sustainable because they create so much pollution when you are creating them. You're kind of offsetting the pollution during the build phase versus the operation phase.
Right.
A lot of that pollution, Ralph, comes from mining and shipping and, kind of creating these rare earth metals from China. That does pollute so much. So if you can cut that out, at that point, Ralph, there's no reason not to have an electric car. It is, and
that's right.
Honestly, it already is that way, but even more so. So
yeah,
there you go.
Yeah, and Ben, related to that, real quick, if you think about the future where we could go, this kind of motor would be a tremendous asset. Again, mixing the rare earth metals part of the equation, materials rather, I should say. And remember, a few weeks ago we talked about sodium battery technology instead of lithium. So that also could be a monstrous advance. So on the horizon, hopefully not too far off in the distance, could be a combination of technologies that would make making EVs, to your point, much more sustainable, much more friendly, and much less expensive. And away we go from there.
Definitely. Ladies and gentlemen, I know that we're all waiting for the next great battery revolution. It's going to take breakthroughs like this, but also, don't worry, folks, things are getting better every single day, every single year. Things are getting better. So, Ralph, I want to thank you so much for coming on the show and sharing these stories with us. And everyone else, if you want to find more Ralph Bond-Wicks, search there or check out the show notes. We'll have a link there. Ralph is here every single Friday. You can set your clock to it. Cough, cough, except next Friday. Ladies and gentlemen, Ralph will not be here. In fact, I won't even be here. But we'll be back the following week with more great stories. So until next time, everyone, have a great day. Have a great weekend. Bye, everyone.